All right, welcome back. So here we've got another integral, integral of t to the fifth over t squared plus 4. Bothers me again because this is one that you could do without trigonometric substitution. Like I said, there's more than one way to solve these problems, okay? So let's do it without first. Let's say we set u equal t squared plus 4, okay? And it takes a little bit of trickery. But we could say, well, t to the fourth is then u minus 4 squared. We've got a t. du is, of course, 2t dt. So we're going to get 1/2. And the reason I'm doing this quick is because this is not really the way that I want you to do it. Okay? And this you could integrate pretty easily. Okay? But we're going to do this with a trigonometric integral. Okay? So, or with a trigonometric substitution. We've got t squared plus 4. So looking back at our thing, that's a t squared plus 4. Oh, that's going to be x equals a tan theta. Okay, so t equals 2 tan theta. Okay, and if you can't remember, just remember sine squared of theta plus cosine squared of theta equals 1. Let's divide that out by cosine. And then we say, oh yeah, this matches this. Okay? So, running this through, by the way, dt is 2 secant squared of theta d theta. Okay. So running it through, we get, let's see, 32, that's 2 to the fifth, tan to the fifth of theta, dt, 2 secant squared of theta, d theta, t squared plus 4, that's going to be square root of 4 tan squared of theta plus 4. But this is 2 secant of theta. Okay, so now we can continue. We can say, okay, well, this is 32 integral. We've got tan to the fourth of theta. Should say 60. Yes, the 2 canceled, sorry. This 2 cancels with the 2 here. One of these secants cancels with that one. That's how I get this. Okay? I'm pulling out one of the tangent of thetas. Why? Because this is the derivative of secant squared, right? Tangent to the fourth is secant squared theta minus 1 squared. Okay, so now we're going to let u equal secant theta, du is secant theta, tan theta, d theta. So we get 32 integral u squared minus 1 squared du. Okay. 32 integral u to the fourth minus 2u squared plus 1 du. It's 32, sorry about that, u to the fifth over 5 minus 2u to the third over 3 plus u. There is a point to all of this, by the way, okay? Otherwise, I'd say I'd leave it for you guys to do, but there is a point why I'm doing all this, because I want to show something. Now we have to go back. U is secant of theta, so that's 32 secant of theta to the fifth over 5 minus 2 secant theta cubed over 3 plus secant theta plus c. Now, our original integral was in terms of t. Okay, let's bring this down again. T equals 2 tan theta. Okay, so now if t equals 2 tan theta, that means we have this triangle. Theta's here, t is opposite, 2 is adjacent, and then here we have square root of 4 plus t squared. So we look at this triangle in order to come back to t. Okay, so our secant of theta in that triangle is going to be 2 over the square root of, oh, sorry, I have it backwards. I was about to do cosine. Square root of 4 minus 4 plus t squared over 2. Okay. So now that means we get 32 times 4 plus t squared to the 5/2 over 32, and we need 1/5 of that. Okay, minus 2/3 4 plus t squared to the 3/2 over 8. Okay, let me make this parenthesis different. Plus square root of 4 plus t squared over 2. All of that plus a c. Okay. Oh, all right. See y'all in the next video.